Alright class, today we're going to look at our forward reverse circuit. Now many of you guys have gone through this circuit several times, so we're just going to describe the function and the whole composition of the circuit. So we have the schematic diagram here in front of us. We're going to start by describing the components. We have our circuit breaker here. You see it goes across all three phases and is mechanically interlocked, so you have to open and close all three phases at the same time. And the circuit breaker is used to protect the conductors from being damaged when you have overload current. Then we have our isolator. Our isolator also has a mechanical interlock, so you have to open and close all three phases at the same time, and it is used to isolate the supply from our circuit. Then we have our main contacts, and we have three main contacts for the forward contactor coil and three main contacts for the reverse contactor coil. We have our overload coils. We have our three-phase motor. Then on the control side of the circuit, this side of the circuit is the power side. It provides power to our motor. This is the control side of the circuit. We have our normally closed stop button that breaks current flow to the rest of the control circuit. We have our normally open forward start circuit, which is a push button that's normally open, and we have a similar push button for the reverse start. We also have our holding contacts or auxiliary contacts, and we'll discuss that further when we go through the operation of the circuit. We have normally closed contact that is related to our reverse coil that is in series with our forward coil. We have a pilot light that is in parallel with our forward contactor coil that will indicate when the motor is running in a forward direction, and we have our normally closed overload that will open the control circuit when or if there is overcurrent going through the motor, and so protect the motor from damage. Alright, so let's look at the operation of this circuit. If we want the motor to go in a forward direction, we would manually squeeze down the forward start push button. This would allow current to travel from the phase through the start button and energize the coil. The coil being energized will close the main contacts. 1, 2, 3 main contacts, and we realize that the F indicates that these are the forward main contacts, allowing current now to run through to the three-phase motor, and so we'll have current entering the motor and the motor will start to spin in the forward direction. Also happening when we release our finger from the forward button will return to being normally open. The motor, however, will continue to spin because when the forward coil is energized, it also closes these auxiliary or holding contacts, and so current can still flow through to the coil, keeping it energized and keeping the motor flowing in a forward direction. There is also this normally closed contact that will become open when the forward coil is energized. This prevents us from energizing the reverse coil and so closing the main contacts of the reverse contactor coil, and so prevents short circuit. So this mechanism prevents the motor from being operated in a reverse mode when it's already being operated in a forward mode. So we reach the point where we press the stop button and the motor stops spinning, or the coil becomes de-energized, opening the 1, 2, 3 main contacts and also opening the hole in contact. And so this prevents current from flowing to the 3-phase motor. We then close the reverse start push button. This allows current to flow to energize the reverse contactor coil. This then closes 1, 2, 3 reverse main coils, and so current will now flow through these main coils to the motor. We must, however, note that the reverse contactor coil switches 2 phases that are connected to the forward contacts. So for our example here, the 3rd phase contacts are the same, so current would still flow directly through this phase. But for phase 1, this current would travel through and go to the motor where phase 2 was, and phase 2 will now travel through to phase 1. This creates a difference in rotation of the magnetic fields in the motor and causes the motor to spin in the opposite direction. So this is the main thing with a forward reverse control circuit. It switches 2 phases from the forward mode to the reverse mode, and it is through this connection here where we take phase 1 and we run it through phase 2, and phase 2 in the reverse mode runs through phase 1. So we have pressed our reverse start button. Current flows through the reverse coil, energizing it. It closes 1, 2, 3 main contacts. Current can now flow to the motor, and the motor spins in the reverse mode. It closes the auxiliary contact, and so although we release the start button, current can still flow through to the reverse coil, keeping it energized. We also note that there is a pilot light that is parallel to the reverse coil, and it will indicate that the motor is spinning in the reverse direction. Also, for safety again, we have a normally closed contact that is in parallel with the forward coil, and it would open when the reverse coil is energized, preventing any current at all to flow to the forward coil. So they can't be energized at the same time. Again, let me finally note, the overload coils here would sense any overload to the motor and open the normally closed contacts here, thus opening, de-energizing any of the coils that would be energized and opening the main contacts, preventing current to flow to the motor. Hope you get a full understanding of this operation and components of the circuit. We'll be practicing more of actually connecting the circuit up and seeing how it functions.